Hello. Today we'll look at labor cost variances. When actual cost of labor incurred differs from what the expected cost is, then we say we have labor cost variance. There could be several factors that could be responsible for this. So today we'll be looking at the labor total cost variance. Yes, the actual cost is different from what the expected cost is. Then we'll go on to further try to look at what could be the responsible factors for that cost variance. It could be as a result of rate being different. Yes, we plan to pay at a certain rate. We ended up paying at a different rate. Or it could be a case of an efficiency where we have a certain number of hours, which is what is allowed to produce an item, and eventually we use an hour or labor using R, which is different from what that standard is, then that could also be responsible for the labor total cost variance itself. Yes, we have a question on the screen. You might want to pause this video. So you go through that, then you come back. All right, welcome back. So in the question, we have the budgeted section right up there, and we have the actual section right down there. Anytime you're trying to solve a variance question, you will always have the standard information and also the actual information. So this has been sectioned into two. So right away, we go into solving this. But before we go into that, I usually advise students that it's so much important, or it could be very useful for you to try to put out your information in the standard cost card format. This would go a long way in helping to identify which of the figures you are trying to address. So from the budgeted information I have here, I can see that I have 3,000 hours as in planned to produce 1,000 units. From there, I can figure out that the standard hours is actually 3 hours. That means we need 3 hours to produce a single unit. At what rate? What rate do we intend to pay do we intend to pay 1 hour? If we're planning to pay $15,000 for 3,000 hours, then what we are trying to do is to pay at the rate of $5 for every single hour. Then that gives us a standard cost of $15 per unit. Remember, this is per unit. From this, we are able to go further. So I have my total cost variance. If I'm trying to address my total cost variance, then I'm trying to address this 15 because the total talks about the units being produced. Then 5, this has to do with the rate variance, and the 3, ordinarily hours, has to do with efficiency. When you talk about efficiency, you're talking about hours. So let's start. The labor total cost variance. That's described as the model variance for labor. That's the total cost itself. So what is the plan and what's happened? So the labor total cost variance, the standard cost, or I describe that, let me describe that standard labor cost of actual production. How many units did we produce? We produced 1,100. 1,100 units have been produced. 1,100 units have been produced. Yeah, 1,100 units have been produced from the actual section. And the plan is to pay at the rate of $15 per unit. So you can see from the standard cost format we have down here, we can see that we are actually trying to address this $15. So the standard cost itself is to produce $15, spend $15 of labor for every unit. Now we have produced 1,100, so we expect the total labor cost to be 1 multiplied by 15, and that's 16,005. Then we ask, what is the actual cost of labor? How much did we pay? From the information we have here, we paid 17,680. So we have a difference of 17,680 against 16,500. I plan to pay. The expectation is that I will spend 16,500. I ended up spending 17,680. Invariably, that tells me that I have overspent, I've gone beyond budget, and that is an adverse variance. Adverse variance in that instance. So that is the labor total cost variance. We can then go on to further compute the sub-variances on the labor total cost variance. And the first we can have is the labor rate variance. For the labor rate variance, we're trying to check what happened with this $5. Did we actually pay $5 for every hours paid? For every labor hours paid. So we ask ourselves, what is the standard cost of labor hours paid? The rate is to pay $5 for every hours we pay. How many hours do we pay? We paid for 3,400 hours, and the standard is to pay at the rate of $5 per hour. So the expectation is that we'll pay 3,400 multiplied by 5, that's 17,000. Then we ask ourselves, what is the actual cost of labor hours? And the actual cost happens to be 17,680. We are expecting to pay 17,000. We ended up paying 17,680. That means we paid more than what we budgeted for, and that can also be described as an adverse variance. Then one more variance we can also compute under the labor variances is the labor efficiency variance. Efficiency variance. Like the word efficiency, it talks about time. How well was time? How well did we manage time? So we ask, what is the standard allowed time for the units that have been produced? Yes, you have come to say you've produced 1,100. 1,100. The agreement from the standard cost format we have here, the standard is to use 3 hours to achieve a unit. So 3 hours per unit. And now that 1,100 units has been produced, then we expect that a total of 3 multiplied by 1,100 hours should have been used. That's 3,300. I put the unit right up there. Hours should have been used. A total of 3,100 hours should have been used in the production process. So we then ask, what is the actual hours worked? In this question, we can see that the hours worked, there's no separation between hours worked and hours paid. So we still take the hours worked as it. So the hours worked equals hours paid, and that's 3,400. So if I compare these to 3,400 and 3,300, the allowed time is to spend 3,300 hours, but you ended up, the number of hours spent happens to be 3,000. That means more time is spent than what is required. That's obviously an adverse variance itself. And we don't leave our variance in anything other than monetary terms, so we multiply by the standard costs of labor per hour. And the standard cost of labor per hour happens to be $5. So we multiply by $5. So if I multiply 100 by $5, 100 times 5, that gives us, sorry, that's 100 by 5, that gives us $500. Obviously, that's an adverse because more time has been spent than time allowed. From here, just like I explained earlier, the labor total cost variance can actually be sectioned into these two. So by the time I sum 680 adverse plus this 500 adverse of efficiency, we have the labor total cost variance. What are situations where our hours paid is different from hours worked? So people can only work for lesser time. It's not ideal. We don't expect that hours worked will be higher than hours paid. So normally the usual situation is to have hours worked being lower than hours paid. If you have such situation, that means we have a case of an idle time. An idle time will just be the difference between the hours paid and hours worked multiplied by the standard cost of labor per hour. And that will always be an adverse variance because you're paying for a time that people were not engaged, actively engaged in production. In that instance, just take note here, you have hours worked there, you have hours paid here. If it is different, then I would have used the hours worked right here. Thank you so much. I hope this is useful.